Hello everyone, my name is Abner Junior Lusong and I'm currently a graduate student at East Texas A&M University. For my presentation in operating system, I have chosen the topic, a comparison of real-time operating systems or RTOS in the Internet of Things. The agenda for this presentation are the following. Overview of Internet of Things and real-time operating systems. What is the relationship between IoT and RTOS? What is the characteristics of RTOS for IoT? How are 5 RTOS in this presentation are good candidates for IoT? Internet of Things are small devices designed to gather and share data with other devices, or analyze the gathered information to generate insights. These devices are found all around us, like, for example, wearable devices that we use every day, our home, or not most home, but some of homes which we can have control. The automotives we drive, they can be found in hospitals, aerospace, and industries. They can either be consumer or industrial. They are either connected to the internet or their own network, gathering data from sensors or triggering actuators. These smart devices are so small, they have limited resources. What resources? They are the power or the energy or the space to fit. And RTOS, or real-time operating systems, are perfect for successful and efficient operation of IoT because of the resource constraints mentioned before. RTOS is preferred due to its low latency, reliability, and deterministic behavior. They are reliable, predictable, high performance, compact size, and ability to scale according to system requirements. Bottom line, RTOS is technically perfect for the job for the Internet of Things. These are the criteria chosen to be studied. Scalable. First, we want a scalable RTOS that would work with a wide range of devices. What devices are we talking about? These are microcontrollers or processors. The difference between microcontrollers and processors is that the processor is CPU only, higher power consumption, and does not have a native and high costs, while microcontrollers are bundled with CPU, ROM, RAM, and other peripherals. It has lower power. It has a native real-time control by RTOS, and it's very low cost. Modular. Modular means we need to choose only the component that we need, affecting the footprint for the development or when it's runtime. Connectivity options. So we want to have a lot of options for our connection. They can be Wi-Fi, Bluetooth, USB, or Ethernet. Next is we want to have safety and reliable. Safety critical applications need certifications for their standards, for able to do testing, checking, and auditing, and it's known to be globally acceptable or known globally. And last is the energy efficient. We want our RTOS to be not consuming a lot or has low consumption of energy, or maybe has a power saving capability. The first from the list is FreeRTOS. This is one of the popular, and this is open source. It was originally developed by Richard Barry in 2003 and later maintained by Real-Time Engineers Limited. In 2017, Amazon Web Services assumed stewardship. Lightweight, it's a lightweight microkernel that provides essential real-time operating system features tailored for embedded systems. It supports both preemptive and cooperative scheduling policies. It has a modular design that allows to add libraries, for example, FreeRTOS plus TCP, Core MQTT, and others. Other libraries are FreeRTOS plus POSIX library, Bluetooth Low Energy library, and AWS related libraries, which is displayed on the table, namely AWS IoT Over-the-Air, AWS IoT Device Defender Service, IoT Signature version 4, AWS IoT Jobs, AWS IoT Device Shadow, and AWS Split Provisioning. These libraries makes it easier for the developer to connect it to the cloud. And the connectivity options available are Wi-Fi, Bluetooth, Ethernet, and cellular. This RTOS supports the following architectures: ARM Cortex-M, ARM Cortex-A, RICB, S86, S86-64, MIPS, and more. Since safety attributions are not supported, there are other options like using the safe RTOS. And the tickless idle mode is one of the power-saving consumption features. It means it disables the tick interrupt during idle periods when notas are ready to run. The system then remains in a deep sleep state longer or only when needed. When the tick is enabled, FreeRTOS adjusts the tick count to maintain accurate timing, allowing for significant power savings without compromising system responsiveness. Second is Zephyr. Zephyr is a robust microkernel open source real-time operating system designed for embedded in IoT applications. It offers real-time capabilities with support for both preemptive and cooperative multitasking. It includes a built-in power management capabilities designed to optimize energy consumption. Zephyr supports the following architectures: ARM Cortex-M, RSCB, x86, ESP32, ARC, MIPS, and more. To get to know more architectures or hardware supported, this one you need to go to the page or website, then just search for the list. Moving on, we are looking at the modules. We need to look at the networking modules or external modules that can be applied or integrated. Its availability configurations are Wi-Fi, Bluetooth, Ethernet, cellular, IEEE 802.15.4 LoRa. There are also no certification supported, and the device runtime power management and system managed device power management are the two methods for the built-in power management. RIOT OS is distributed under the LGP LP 2.1 license. It's an open source operating system specifically designed for microcontroller use in the Internet of Things and other embedded applications. It also supports tickless, preemption, priority-based scheduler. Hardware supports including 16-bit MSP 430, 32-bit ARM7, and more. Modules can also be added to the RIOT OS because since a RIOT OS is a microkernel, we need to add modules to add functionality or features. This is known. These features are GNRC and OpenWSN. It depends on what features we need to include. The available connectivity options are Wi-Fi, Bluetooth, Ethernet, cellular, IEE 802.15.4 LoRa. Also, the safety certifications are not supported. For me, this is very, for someone who want to test it out, this is very, I would recommend. For example, you're wanting to try out RTOS, maybe RIOT OS is highly recommended. Pronounced as Micro COS3, it's the third generation kernel from the Silicon Labs. It's flexible, preemptive real-time and priority-based kernel. Features include process synchronization, inter-task communication, resource management, and more. It's designed to be modular, so permitting developers to import only the necessary plugins. It also supports numerous CPU architectures that can be adapted, including ARM Cortex-M series, ARM Cortex-A series, RISC-V, AVR, PowerPC, MSP430, and MIPS. Some of the stocks that can be included are the Micro C Modbus, Micro C USB device, Micro C TCP IP, Micro C USB, and embedded Office Scan Open Stack. So also support Ethernet, but it requires integration for other connectivity options like Wi-Fi and Bluetooth. So the certification included by the ISO 26262. This is required for the industrial and automotive. IEC 61508. This is required for both the industrial, automotive, and medical. EN 50128 is also for the industrial and automotive, and DO 178 for the aerospace. So as mentioned before, these are the certification required for mission critical, safety critical applications. ThreadX. This is created by Bill Laney and introduced commercially by Express Logic in March 1997. In 2023, Microsoft announced the transition of Azure Thread to an open source free MIT license under the stewardship of Eclipse Foundation, changing the name to Eclipse ThreadX. It's a priority-based preemptive scheduling algorithm designed for deeply embedded and high-performance applications. It's a pico-kernel architecture. Unlike traditional microkernel architectures that layer kernel functions, it integrates its services directly into the core. This streamlined design enables extreme fast context switching and service call execution, and making it one of the most efficient RTOS options available. For the hardware support, it supports ARM Cortex-M, ARM Cortex-A, RISC-V, and more. In this presentation, I'm only mentioning some of the hardware devices that supports, but if you could, it's too many to mention if I put it in the slide. So what I'm saying is there's more devices control that listed here. Now, moving on to do for the modular part of the ThreadX, there are limited options like NetX Duo, USBX, and FileX. Also supports the connectivity options Wi-Fi, Bluetooth, Ethernet, and cellular. For the certifications, this is the certifications that we need for aerospace, medical, automotive, and industrial. Applications. This is just some of the applications that we can use or an idea how to apply the RTOS. For FreeRTOS, this has been used in a university for air quality monitoring. For Zephyr, it was applied to a smart toothbrush, commercially used design specifically for children. It makes the process more interactive for children. RIOT OS was utilized in research focused on enhancing safety and security in public spaces with applications in crowd management and area surveillance. So these are the opportunities are limitless. When using the RTOS, it can be in any field. Summary, we have discussed the multiple characteristics of the RTOS for the Internet of Things, but it's not limited to them. We can also add other characteristics. Some RTOS covers more hardware, but we need to identify what is the minimum requirement for our product. Most RTOS are modular and always using stacks to add features. The options for network connectivity varies from each RTOS. Some RTOS doesn't have Wi-Fi, some RTOS only have Ethernet. So this is one also need to think about when choosing RTOS. Also, if you want to, it depends on the industry, and some RTOS are limited with certifications. We need to know if we're going to develop an RTOS for the aerospace, then we need to choose an RTOS with safety and reliable certifications. That's it. That's it for my presentation. Thank you.